All right, here we go. We have pistons of a particular car engine oscillate up and down and complete 20 full cycles every second. Go ahead and underline this. Okay, in 1 minute we're completing 20 full cycles. B is on the top of one of the pistons and is located directly above the center of motion. Figure 1 shows the piston at time t. So I'm going to come down here and write time t equals 0 right here. We know that this is time t, and it's at the very height. So let's look. When we're at time t equals 0 at this position, we can see that the piston is at a maximum height, which is 7 inches above. So I would like you to go here and write 7 inches. And then we should have this figure 2, and then it's at a minimum height, so this is going to be at a minimum height here, and is 3 inches above, 3 inches above, 3 inches above. Now if we go further, it says this center is 30 inches above flat ground. So from here down to the very bottom is 30 inches. From here to the very bottom is 30 inches. Here we go. Let's come back to this right now. All right, so I can see that when I look at this, I have a max height. I have a max height of 37 inches, and I have a minimum height of 30 plus 3 of 33. So directly in the middle here of 37 and 33, directly in the middle, and you could do this however you wanted, but I can see that there's a difference of 4. Does everybody see that? That's a difference of 4. So if I take 4 and I divide it by 2, that means 35 is right in the middle. So it goes 2 up and 2 down. So I'm going to come back here, and I'm going to just do this for myself. I'm going to write y equals 35. I'm going to write y equals 37, and y equals 33. So this is going to be a height, again, of 33. I think it's to our advantage to come off to the side here, and we're going to make a table. And our table is going to have 3 columns. And what's a little bit different about this problem than the other problems we've done is we're going to be working with some decimals that we're just accustomed at this to be using calculators, and that's okay. So this is going to be our points, this is going to be our t values, and this is going to be our height. And our height is going to be represented by s of t. Okay, so we have F, G, J, K, and P. So the first thing I'm going to do is I'm going to go ahead, and this is going to be t equals 0. I'll come back to all of this in just a little bit. We know that we end on 1 after 1, let's see here. Let me go back up here. It can do 20 full cycles in 1 second. So we're going to come back up here in just a second, figure out our t values. Those are the most difficult for this. But let's go ahead and let's figure out height. So this is a height of 37. At G, you're at 35. Then you go down to a minimum of 33. Back up to the midline of 35. And back up to the height of 37. Can I have right now a thumbs up or thumbs down if that's making sense? Now, I think that most people, when they're working with fractions, if they can relate it to dollars and cents, they seem to have a little bit easier time, and so that's what I'm going to do. So I know that this is my fraction right here, 1 over 20, and this is going to represent the length of one period. So I know from here to here is a length of 1 over 20. It's a length of 1 over 20. Now I'm going to come off to the side, and I'm going to divide that. So I have 1 over 20, and that divides into, so 1's on the outside, excuse me, I did that wrong, so sorry. 20 is on the outside, and 1 is on the inside. I know 20 does not go into 1. In fact, it does not go into 10, but 20 does go into 100 5 times. So I know that this length of one cycle is going to be equal to 0.05. So when I get to P, I'm at 0.05. Thumbs up or thumbs down if that makes sense to you right now. Thumbs up, thumbs down. Okay, now dividing that into 4. Remember, our sine and our cosine are going to be divided into 4 equal steps. So here's where I'm going to think about money. So I'm going to take 0.05 and I want to divide it by 4 equal parts. Now look where that decimal is. Now this is how my brain works. My brain works with this. You ready? Just think $5. If you take $5 and you split $5 in half, what are you at? $2.50. Do you guys all agree with that? $2.50? Okay, I'm at $2.50. I'm at $2.50. And if I take $2.50 and I split $2.50 in half, what am I at? $1.25. I'm at 125. So notice where this decimal is. I need to move this decimal back 2 places, 1, 2. So I know right now that if I take 0.25 and I divide it by 4, this is what I should end up with. Okay, so, and let's just make sure here, let's make sure this works. 4 cannot go into 0. 4 can go into 5 one time. 4 can go into 10 twice. 4 can go into 20 5 times. This represents the horizontal distance from one step to the next. So let's come up here. This is 0.0125. Okay, now think of this, just how I did this. I moved the decimal 2 places to the left. So guess what? After I've done 2 steps, I'm not at 250. Guess what I'm at? I'm at 0.0250. Now, if you take $2.50 and you add another $1.25 to it, what are you at? What's $2.50 plus $1.25? It is $3.75. Do you guys agree? But then we're going to move that decimal 2 places to the left. So 0.0375. These are all my positions. These are all my positions. Let's get started. Okay, are you ready? For this function can be written in the part A. Determine the coordinates of each one of these. So I can see this off to the side. I would come up here and write this is 0, 37. At G, we're at 0.0125 and 35. You guys can do this all here looking at my chart. 0.0250 and 33. K is going to be 0.0375 and 35. And P is 0.05 and 37. Let's go on to the next part. Let's go on to this part B. So part B here I'm looking at. So A is going to be my amplitude. That means how far above or below from the center line. We can see that's 2. So I'm going to have A equals 2. It seems like the easier one to do. We have a shift up from all the way to the ground, all the way to the midline is 35. So that means my D equals 35. Okay, got that. We already know that we can take 2 pi and divide it by b. 2 pi divided by b is going to be our period length. Now, I'm going to prefer to use 1 over 20 versus 0.05, just because I think it's going to be easier here. So I know 1 over 20 is equivalent to 0.05. Okay, here we go. I multiplied to get 40 pi equals 1b, divide by 1, and my b value is going to be 40 pi. Now my c value, we're looking at a sine. Remember that when we do our basic sine function with no translations or movement to the left or right, shifting, it goes step 1, 2, 3, and 4, right? Step 1, 2, 3, and 4. So it's starting here at the origin. We can see that it's been shifted to the left. Does everybody see here? So one option here is it's been shifted to the left. Now when we go to the left, what do we represent that with? A positive or negative within the equation? A positive. So our C has been shifted 1 step to the left. Well, what is 1 step? We can see 1 step is 0.0125. Let's go on to the next part. It says on this graph to go up to G, and at G write T of sub 1, and go to J and write T as sub 2. So here's a great example that if you never understood how to do part A or part B, you can still get part C correct. By a raise of hands, how many attempted to answer part C even if you didn't understand A or B? Awesome. So let's look right now. All of these Y values are positive. We can see all of my Y values are positive. So anything that says negative, I can cancel out. Now, what's happening? This is not, it does not say rate of change. You see nothing about rate of change here, so don't get confused with the concavity. We just want to know from G to J, which is T sub 1 to T sub 2, what's happening? Is it decreasing or increasing? It is decreasing. Correct answer is B. Raise of hands, how many of you were able to get that right? Awesome. Let's go down to the next part. Now we're going to describe the rate of change, which is the concavity. So I'm going to write down that the function S is decreasing on the interval T1 to T2 and has a what are we looking at here? It has an increasing rate of change, which makes it, let's test you. What's a concavity? Concave up. Good. Concave